Hello, my name is Justin. I'm a part of Team Mauja, and this is our enhancement proposal for the Polywood Industries case study in ENGT 581. Polywood Industries is a manufacturing company that manufactures high density polyethylene plastic recycled furniture. This furniture is primarily made out of that recycled HDPE, which comes from milk jugs, detergent containers, and similar plastics. The manufacturing process includes recycling, extrusion, and assembly. Both sensors and technicians are involved in ensuring precision and quality during the manufacturing process. During this case study, we'll focus on the three key production phases: recycling, extrusion, and assembly. Examine the various sensors that are included. Look at the current integration of smart technology in the process. Look for opportunities and further improvements to enhance things like efficiency, problem detection, and operational seamlessness. Specific enhancements will be proposed for each phase. The assembly underscores the significance of leveraging sensor data for real-time adjustments. An increased sensor integration in the assembly phase is highlighted to augment efficiencies and quality control. During the current operation, the recycling process utilizes an optical sorter and uses color sensors to identify then sort plastics by wanted and unwanted colorization. It does this without the need to store or report any information and operates autonomously. There is then a resin tracker after the pelletizer. This resin tracker tracks the total manufactured quantity and hourly manufacturing rate for its current shift. This data is utilized as passive monitoring, though a significant decrease in the shift could signal an issue somewhere in the process. In the extrusion process, we have multiple sensors that are being utilized. This information is recorded and able to be referenced to later. A feeder within the extrusion tracks the pounds per hour and pounds per shift continuously and operates via simile to that resin tracker in the recycling process. With the extrusion process continued, there are 6 barrel zones and 4 die zones that are all being monitored. The 6 barrel zones control the temperatures. There are also 4 die zones that monitor melt pressure, melt temperature, motor load, and RPMs of the screw machine. The size of the extrudate bubble is also measured in the cooling process by a laser sensor. A proportional integral derivative controller, or PID controller, is utilized to correct any discrepancies identified by the laser systems. Vacuum pressure is measured in both of the cooling zones by a pressure sensor. A laser micrometer is used to measure the thickness and width of the product to allow the opportunity for the technician to change the dimensions of the product if needed. Moving on to the assembly, it utilizes a box machine with a possible laser micrometer that is used to cut, crease, and glue the boxes for shipping. The manufacturing CNC operates to machine grooves and holes in the plywood material before assembly occurs. The CNC mill, a controlled module, collects the data, shows the operator on the LED screen to provide some data information. After items have been boxed, packaged, and labeled, a serial code is scanned by the technician, and this data is used to track the production rate and the operator efficiency. We are suggesting some strategic enhancements to the recycling process. We do suggest for the whole process to integrate a data center and a cloud-based server. This will allow data tied from all of the sensors that have previously been mentioned and some that we are going to add to be monitored real time for predictive maintenance and efficiency, quality, and quality control. We're also going to suggest including a linear variable differential transformer sensor. This sensor can be added after the shredder process. So the sensor will measure object geometry and will notify any outliers outside the ideal 1 to 4 inch range. So the benefits of the sensor include presenting advanced knowledge to the shredder's performance, and if any pieces are making it through the shredder, a size that could cause a problem later in the process. The same sensor can be set up on the grinder, similar manner, but the calibration to set 3/4 of an inch to an inch. The installation process of these sensors will take 1 to 2 hours and can be done so while the rest of the line continues. It requires some calibration, debugging, potential troubleshooting. Can take up to 30 minutes to complete. This will ensure that pieces are not too large to properly function in the float tank. We're also suggesting upgrading to Industry 4.0 network PLCs. So the PLCs that are currently being utilized are Industry 3.0 technology and utilize passive monitoring. So with upgrading the programmable logic controllers to network programmable logic controllers, they can be tied into that data center and that IoT or Internet of Things gateway, as all of the controllers can communicate and make on-the-fly adjustments real time. The controllers will be upgraded with microprocessors or MPUs. These MPUs will be utilized to execute the programs and catch any errors that compromise the system safety. So the PLCs and the controllers will be upgraded and tested. Although we don't know the exact amount of PLCs and MPUs being utilized, we assume this will take a few days to integrate, calibrate, and troubleshoot. For the assembly, we're going to suggest utilizing line automation robotics in that process. So currently between the planks, the chop saw, CNC mill, assembly, and packaging, this is all manual labor being utilized. By implementing line automation, utilizing ultrasonic position sensors for accuracy, we can automize this process and increase production. In conclusion, Polywood Industries manufacturing operations demonstrate significant integration and smart sensors across stages. Further enhancements are needed to improve efficiency, problem detection, and operation smoothness. Overall, Polywood has embraced smart technology, smart manufacturing principles to pave the way for increased automation, data analysis, and optimization. Leveraging smart sensor data and decision-making processes can enhance Polywood's competitive edge, sustainability efforts, and operational excellence in the future of the manufacturing industry.